Swayam Prabha. Digital India. Educated India.
In the previous lecture, we looked at control sources. Now, so far we have looked at two terminal elements and also control sources. And what we have done is to describe the relationship between the voltage and current of these elements. In this lecture, what we will look at is the power and energy in these elements. Okay. Now, before I get started, are there any questions regarding the previous lecture or any of the previous four lectures? Okay, I think now you are able to see the journal as well as the webcam video. Is that correct? If someone is not able to see that, please send a message in the chat window. Okay, I think now you are able to see me. So if there are any questions regarding the topics we covered in the previous classes, please ask questions. You can type into the chat window. Okay, let's continue with the lecture. Now, we looked at a number of elements, the independent sources, voltage and current source, and also the resistor, capacitor, and inductor. Okay, and each of these is defined by some relationship between the voltage across the element and the current through the element. Okay, and you know what these relations are. In this case, I have shown all the elements with this passive sign convention. Okay, that is, if V is defined positive on top and negative on the bottom, I goes into the upper terminal, the terminal on top. Okay. Now, this product VI, that is the product of the voltage across the device and the current through the device, has some significance, and that is nothing but the power that is going into the device. Okay. So with this sign convention, with the passive sign convention, V times I is the power that is going into the device. Okay. Now this either can be constant or changing with time depending on V and I. Okay. If V or I is time varying, it's possible that this power is time varying, and in that case, it is known as instantaneous power. Okay. So this is what the instantaneous power is, and this, if it is positive, the power is going into the device, and if it is negative, power is drawn from the device. Okay. On the other hand, if it is negative, that is P of t is less than 0, power drawn from the device. Okay. So this is how the power is defined, and it's extremely important to follow the passive sign conventions, that is the appropriate signs of the voltage and current across the elements. Okay. Now what we will do is we will look at each of these elements and see what the power is. Okay, because we know that the element enforces certain relationship between the voltage and current. That means certain things for power, and we'll look at that shortly. Okay. Let's take a resistor. We have some V and some I, and we know that V equals I times R, where R is the resistance value. Okay. Now the power P of t is V times I. Now in general it can be dependent on time. Now the resistor doesn't care if V and I are changing with time. At each instant of time, the voltage is proportional to the current at that instant of time, and the proportionality constant is the resistance R. Okay. So if I substitute V equals IR from here, I will get I square times R. Alternatively, if I substitute I equals V divided by R, I will get V square divided by R. Okay. So now, given this type of relationship, please tell me what is special about this. Okay, we have V square by R or I square by R. So what does it signify? Okay, there are a number of answers, but I think probably the question was a little vague. My question is, please concentrate on the fact that we have I squared, that is square of some quantity, or V squared. So what does that signify? So has somebody answered? V square and I square in this expression imply that T is always positive. Okay, or it could be 0, but it's never negative. Okay. So this means that a resistor always absorbs power. Okay. You can never get power out of a resistor. The resistor always absorbs power. And typically we also say, instead of absorbs, dissipates. Power. Okay. So in practice, if you connect some voltage across a resistor, some current will flow, and the resistor absorbs the power of V square by R, and it will go on heating up. Okay, so that's what usually happens in, that's what happens in practice. Okay. The point is that the power is always positive, which means that the resistor absorbs power. Okay. So I think this is pretty clear. Now let me take some other elements. Let me take a voltage source. Okay, that is, I have V equals V naught. That is, the voltage of the voltage source is this quantity V naught, and I have some current through the voltage source. Now I would like answers from the participants. What do you think this does? Will it absorb power, or what is the condition? Or can we say anything about it at all? Can we make any statements about what the power is going to be in a voltage source? Okay, I see a number of answers that some of you say it absorbs power and some of you say it provides power or it delivers power and so on. Okay, now the fact is that you cannot tell just by looking at this. It can do either. See, the point is P equals V times I. Now let's assume that the way I have defined it, V naught is positive. Okay, so let's say V naught happens to be 5 volts. Okay. Now the property of the voltage source is that the current can be anything. It constrains the voltage across it to be V naught, but the current can be anything. Now, if the current is positive, a positive current is flowing in the direction shown, P is V naught times I, and I've already said V naught is positive, and that will be more than 0. Okay, in this case, it absorbs or dissipates power. Okay, and if I is less than 0, that is, a current is flowing out of the positive terminal, then I is negative, and P equals V naught times I will be less than 0. It delivers power. Okay. So if you have a voltage source, you cannot say that it is going to definitely absorb power or delivers power. Depending on the configuration of the circuit, the current will be either going into the positive terminal or coming out of the positive terminal. So depending on these things, it can either absorb or deliver power. Okay. Now, we also know the IV characteristics of the voltage source. V equals V naught. This means that I, V, and this is the IV characteristic of a voltage source of value V naught, and in this case I have assumed V naught to be positive. Okay. Now these axes divide the plane into 4 quadrants. Now please tell me in which quadrant the voltage source would absorb power and where it will deliver power. That is, the value of I can be anything, right? You can see that the characteristic of the voltage source is in the first and fourth quadrants. So if my question is, in which quadrant should the voltage source be operating in order to absorb power? Again, there are some answers, and this is really simple, okay? Because in this quadrant, in the first quadrant, V is more than 0 and I is more than 0. So obviously the product is positive, okay? In the first quadrant. And in the fourth quadrant, V is more than 0 but I is negative. So obviously P is IV, which is less than 0. So this delivers power if it is operating here, and this absorbs power. Okay? So if the voltage source is operating in the first quadrant, it absorbs power. If it's operating in the fourth quadrant, it delivers power. And what is meant by operating in this quadrant? In the circuit, the current value happens to be such that it is in the first quadrant. Okay. Similarly, when I say in the fourth quadrant, current value happens to be such that it's in the fourth quadrant. This is just another way of putting whatever I said earlier. If I is less than 0, it will be in the fourth quadrant. Okay. Now, we can also take the case where this V0 happens to be negative. Okay. I will show this in red. If V0 is negative, then the characteristic of the voltage source would be over there. Now, in which quadrant would it be absorbing power, and in which quadrant would it be delivering power? Again, there are a number of answers, but the principle is extremely simple. You look at what the signs of V and I are, and from that you determine the sign of V times I. Okay. In the second quadrant, V is smaller than 0, voltage is negative, and the current is greater than 0. So this is the same as this one. Okay. As far as the IV product is concerned, so in the third quadrant also it delivers power. In the second quadrant, it delivers power, and in the third quadrant, when V and I are both negative, it absorbs power. Okay. So this is the way it is, and you may be asked, let's say you have a circuit with a number of sources, and whether it is absorbing power or dissipating power in a particular condition. You have to see whether which quadrant it is operating in. Okay. Finally, you just have to calculate the product of V and I with the appropriate signs and decide whether it's absorbing power or dissipating power. Okay. And in general, whether it's a voltage source or whatever element it is, in the IV plane, we know that I times V is positive in the first quadrant, and I times V is positive in the third quadrant also. So the element, if it is operating in the first quadrant, or the third quadrant, it will be absorbing power, and if it is operating in the second quadrant or the fourth quadrant, I times V will be less than 0 and it will be delivering power. Okay? And there is a question from Sadiq. Please go ahead. Hello? Sadiq? Okay. Now, with this we can clearly see what happens with a resistor or a voltage source or a current source. Okay. First of all, if we had a resistor, what would be the characteristics? It's a straight line passing through the origin. Okay. So the straight line's the resistor's characteristic would be something like that. Okay. So you see that it is only going through regions which are absorbing power. Okay. So a resistor always absorbs power. Exactly the same conclusion we reach from the power being either V square by R or I square times R. Okay. Now if you have a voltage source, it's a positive voltage source with the chosen signs. It can be either here, or if it's a negative voltage source, it will be over there. Okay, it will be one of these two. Now you can see that it's either it could be either absorbing power or delivering power. Okay. Now similarly, if you had a current source, a positive current source with the chosen signs would be here, and it can be either delivering power or absorbing power. You have to actually calculate the voltage across the current source to figure out what it is doing. Similarly, if I naught is negative, if the current source has a negative value, then also it can be either delivering or absorbing power. Okay. So again, you have to calculate the voltage across the current source to be able to tell whether it is absorbing power or delivering power. Okay. I think now it must be pretty clear. I did the voltage source in more detail, but it must be pretty clear that even the current source can be either absorbing power or delivering power. Okay. Any questions about this? Any confusion? Now, there are some questions, maybe some confusion with the negative source. A negative source simply means that the voltage value is negative. That's all. That's all you have to do. Okay. So just to get some practice, let's do a couple of problems which are very simple. Okay. What I will do is, I will connect, when I write plus minus like this and say 5 volts, it means that in this polarity it is 5 volts. Okay, that is the meaning of the symbol of the voltage source. And similarly, I write 2 amperes like this. That means that 2 amperes is flowing from bottom to top. Okay. Now, please answer this. Now, we have 2 sources in the circuit. One is a voltage source and one is a current source. Now, let's try this. I'll try a poll for the first time. You can answer with the poll. Please mark the choices once I announce the poll. Both are absorbing power, or both delivering power. The voltage source is absorbing and the current source is delivering power, or the current source is absorbing and the voltage source is delivering the power. Okay, so these are the choices. Let me try the poll quickly. Okay, you should be able to see the poll. Please answer if it's A, B, C or D. I think those of you who are sitting in front of computers, please try to answer the poll. And those of you who are in an institution in front of a screen, maybe you can announce your majority opinion to the mentor and then they can enter the poll. Okay? Please try that. This is a feature of this Adobe Connect which we can try and use. If it is useful, we will do it more often. Okay? And I think so many of you are seeing quiz shows and lots of things with SMS voting, so you should be very comfortable with this type of, this mode of answering questions. Okay, I think you can see the participants' answers, and in fact it is correct. The majority opinion says it is C, the voltage source is absorbing power, and that is the correct answer. Okay, and in this case the answer is quite simple. What we do, I mean, always when you are not sure, and especially in the beginning when you are just studying things, just be systematic and calculate the power or anything else systematically. Okay. Now, for the voltage source, if I take V in this direction, passive convention says I has to be in that direction. Okay. Clearly, we see that V is plus 5 volts here by the way I have defined the voltage source, and I is 2 amperes. Okay. Clearly, V times I is plus 10, and the product of voltage and current gives you watts. Okay, this is something you would already be familiar with, and it's positive. Similarly, if I take the passive sign convention for the current, if I take V like this, that is 5 volts, this means that I have to take I in this direction, and that is minus 2 amperes. 2 amperes is flowing from bottom to top, which also means it is flowing, minus 2 amperes is flowing from top to bottom. So, V times I for this is minus 10 watts. Okay, so that means that the current source is delivering 10 watts of power, which is going into the voltage source. Okay, now clearly these choices A and B are a little absurd. I mean, if you have a circuit with only two sources, it cannot be that both are absorbing power or both are delivering power. Okay, because that violates basic conservation of energy principles. If both are absorbing power, then you can ask where is it coming from. Similarly, if everything is delivering power, you can ask where it is going. Okay, so with only two elements, it's the only possibility is for one of them to be delivering power and for the other one to be absorbing power. In this case, the voltage source absorbs power. Okay. Now, just for a little more practice, I will give you one more question.